Hey guys, Sebastian from Madrigal here. This is part 6 in a video series where we create a Vulkan backend for the Basis game engine. If you haven't watched the previous parts, be sure to do that first so you know what we're doing. Right, so last time we pretty much wrapped the swap chain logic, at least for the time being. And in doing so, we worked a little bit at the render targets as well. And we essentially implemented render targets as swap chain managed render targets, but we didn't implement render targets just as normal off-screen render targets where you give it essentially a texture and tell it to create a render target for the texture. And the reason we didn't do that is that we haven't actually implemented textures yet. So I was thinking this time we will spend some time implementing texture VK. So this is the class, this is the texture interface, but this is essentially an empty class right now. And if we're considering that we want to implement textures right now so that we can sort of finalize the render target class, we want to look at how textures are used to initialize render targets on other rendering backends. So I had a quick look here at the D3D11 render target. And if you remember, we have this is swap chain render target boolean. Now this is set to true when we create a swap chain render target, and as we previously mentioned, that part is already done. So we have this if here. If we're not doing a swap chain render target, then we have to essentially do this whole thing. And what we're doing here is that we're iterating over the render target attachments that come in as part of the description, the render target description. We cast them into the correct type, so texture D3D in this case. We get some metrics from them. And then we proceed to essentially create render target views into those. Now, Vulkan doesn't work with render target views. It has something called image views, which are used for the same thing and other things as well. But I'm not super excited about doing it this way, where the render target is actually the one that creates these image views. I think like a texture class should be responsible for its own image views, because image views are used for all kinds of things, not just render targets in Vulkan. So I think we'll look at this. We'll use this as an inspiration for how to do the same thing in Vulkan, but not do it quite in this way. So let's just start and see where that takes us. So I'm going to drag this header to the left side and have the CPP on the right. And as usual, we can use the VEZ documentation to get going, essentially. Right, so images are represented by VK image, so the native Vulkan image type, and are created by calling VEZ create image. And what VEZ gives us when it comes to images and buffers is that it manages the memory for us, which is super nice. And we get something closer to D3D11 or Metal, where you essentially tell the system, you tell VEZ what you're going to do with the image, and it figures out what kind of memory you need for that image or buffer, and then it allocates that for you. So that's super nice. And right, so we need a VEZ image create info. We need the VEZ create image, and that gives us like a VK image handle that we can use. So let's start looking at what we actually need to store here in this texture class. So as usual, I will add the render device VK. This is something that we do with essentially every class that we implement. That's actually good. And then we have the VK image, which we just looked at in the docs. So this guy will represent the Vulkan image, which is wrapped in this texture VK. But then, as I mentioned previously, we kind of want the texture class to be responsible for managing its image views, so that we can do essentially this thing, but we do it inside the texture class. And so what I was thinking is I would do something a little similar to what I do in D3D. So in D3D, this is the direct 3D version of this class, right? And here you can call get SRV. SRV is a shader resource view. That's a DirectX or Direct 3D concept, which is sort of like a, or shall we say the other way around, a VK image view, which we will create here in a second, is essentially like a mix between a shader resource view and a render target view in Direct 3D terms. So I'm thinking that we would actually sort of copy this and have these kinds of like get image view, similarly to how we have get SRV here, because then the image view can be bound into many things. It can be bound as shader inputs, and it can be bound as render target attachments and whatnot. So it makes sense to kind of copy this pattern. Anyway, let's start with doing the same we do on the right there, where we return the image. If someone wants the image, they should be able to get the image. So get VK image, return VK image, right? And then here on the D3D side, when you call something, it creates like this mini struct SRV here. You can have a maximum of 4 apparently. I think we'll need much more than that on the Vulkan side, because we use image views for almost everything. But here you have a maximum of 4, and they're sort of created on demand. And if you give it the same format, for example, it just returns the same view here from this SRV over and over again. But if you get an SRV for a new format, then it creates a new SRV for you and returns that. So we're going to do the same thing here. So VK image view, get VK image view, and if we want to use this for render targets, we're going to want to actually have the texture array index here as well, because that's something that we'll need when we need to sort of tell it to point to a certain texture array index if we have render targets into an array of textures, which I know for a fact that we do. So same thing, but then just like here we have one without the format, which just returns the same format as the texture, as the comment says, and then we have one with a given format, so we can give the texture format here as well, texture format. Yeah, I think that's it. So we'll have those, and then just like we have a struct here, let's create the same thing here. So we have static. Oh, static! Come on, my hands don't hit the correct keys. So we have max image view count, and 4 is not going to be enough. So I'm gonna make 32 straight away, and then just call it image view. Image view. And we'll have the VK image view, which is the actual view. And then we'll have the array index. And we'll have the texture format. So exactly the things that we input here. And then these guys are gonna, quite simply, there's gonna be like a count for how many we have, the image view count, and then we have image view image views and max image view count, like this. Right. And then we have some things to initialize here, so let's get to it. So we're gonna get the device like we usually do, device, and we should initialize those TDS pointers and sizes. Like so. And then we have the MVK image, which is VK null handle. And we have the image count, which in the beginning is 0. And they get created on demand. Right. And maybe we can do something like this, where we just using like a for loop. Maybe we can mem set this to 0 somehow, but I'm actually just gonna VK null handle. I'm just gonna set this, write these by hand, so what do we call it? Set that to like FF to make it clearly invalid, and then format this would be, I think there's an unknown I'll call texture format unknown. Yes, good. Okay. So now then, we should add these guys, and we can add them here. Excuse me, I'm losing my voice a little bit. Let's hope that's not permanent. Like so. Okay. Excellent. And I think actually this guy is just going to call down into its overload using the format that it already knows about, because it has a texture description, and texture description contains all kinds of interesting things about the texture. So we'll do another one of these loops, and we'll do image count. So we'll try to actually, and just a straight linear search is fine here, because we won't have that many of these. So we'll try to find one that matches the format and the array index. Why is that red? It must be a modifiable L value. I'm not trying to modify it, am I? I am actually. Okay. There we go. Right, so if we find one that matches what we want, then we just return that. So simple. And if we don't, then we'll want to create a new image view. And yeah, this is the place where I often get something wrong, so let's try to not do that. First of all, we can create our own image view element here. So array index is texture array index. Then we want the actual view, right? So let's go to render target, and we have this guy here. We can like copy this creation info. This is what we created in a previous video. So image view create info. Well, the image is going to be vk image. That's what it is. And now the view type. Well, we don't really have like a conversion function for that, right? I don't think we do, or do we? Type conversions. Oh, we do. Yeah. Texture type, get Vulkan image view type. Okay. Okay, that's nice. That would mean that we can use this, and we can do something like texture description type to get what kind of image view we want to have. And this returns the correct one. Yeah, that looks correct. And then, I mean, these are the kind of things that, like, when you're, oh, not come on, get format, and format is passed in, so that's fine. And now we get the sub resource range. This is the tricky part. This is the really tricky part. So, depending on how we want to actually use this, this is what I typically just absolutely don't get right. What do we have? We have a base array layer. We have aspect. Oh my god. Base array layer. That's probably the texture array index, right? Right. Oh man. Oh man, this is always such a cluster something. So we haven't set the aspect yet. We have base layer, base array layer. We have base MIP level. We've set that. We set those two actually. We have layer count. And we have level count. So layer count is like the array element count, and level count is like the MIP level count, right? So this would be mTexture MIP level count, right? And then if the type is an array, so if mTexture description type is like that, or I think we have, how many arrays do we have? We have like probably three array types. Oh, not that. 3 array types, right? Oh, is it cube array? Yeah, we don't, there's not, yeah, this cube array, there's no 3D array textures. at least not in basis. Right, so if this is an array, then the sub-resource range layer count would be like the array length minus the texture array index, right? Because it's like how many levels are there left, right? Like if you have a texture array of 5 and then you map like the second one, so the one with index 1, then this would be 5 minus 1 would be 4. Like you have access to 4 left or something. Oh, but then actually, oh man, you can't actually, you can't map. Yeah, this is not gonna work, is it? You can't map like in MIP mapped image view. Let's put another argument here. We can make it a default one, or one that has a default value. So if this is like an attachment to a render target, which we will actually just create, let's make it like false, because like the normal case is that we don't create those, but those ones will. Then, and we need to put it there as well. Like if we have an if this is an attachment image view, right? Right. Then essentially you want these two to be there, right? You want that one, you want both of them to be 1. But if it's not an attachment, then they can be texture arrays, and they can be MIP mapped textures. Yeah, I think this is what we actually want. So if you're going to use this image view to map to like an attachment, if you're going to use it as an attachment into a render target, then these need to be 1. If it's not, then they can be anything, essentially. I think that's like what you want. And then of course, if this, we need like an else here, right? So if it's not an array, then it's just 1, like this. Does this actually make sense? Does this actually make sense? I think it makes sense. And we probably need to like put this here as well, right? Like this. Yeah, this is not nice. This is not really nice, is it? Shaved off an M there. Yeah, I think this is what we want. And then when we have this, we can create it. So to do create image view here, but just so that I don't forget, I'm just gonna do this thing first. So RT attachment view, and then I'm gonna do what's it, image views, m image view count plus equals new view, something like that. Yeah, we'll want to return the new view, like so. Right. Yeah, this got a bit messy, but it's bound to get messy before we're done with this this renderer. Okay, so now that we have this, we can do vk result, result equals vez create image view, and we can do mdevice vk get vk device, and that's address of that guy, and this is address of new view.view, right? And then basis assert f result is supposed to be vk success, and we do the usual thing. Yeah, this is something that we're just gonna have to test and see if it actually works. But I think it should work. I think it should work like this. And of course, the validation layers should let us know if we're doing something really silly here. So yeah, I think the base MIP level is always supposed to be 0. I don't think there's really any case where it's not 0. So that's probably fine. Okay, so obviously we haven't actually created the image itself yet, but we have created the views, and they tend to be trickier. So we can probably just do the destruction thingy here, and we'll do y equals 0. Oh, come on. Y is smaller than image view count, and vez destroy image view device vk get vk device and image views i.view, and then set that to 0. And I guess we might as well just do the destroy image here while we're at it, because it's gonna be really simple to do something like this. Okay, so let's make sure that this actually compiles now. Can't really use it yet, but we can at least make sure that it builds. Okay. So while we're at it, maybe I can do this. How can I? Okay, so I had it almost ready to go, but not quite. So here is here's what I mentioned in the first part. I have this DDS texture from memory VKVEZ, which I tested out with VEZ samples earlier, and it's kind of silly, but it's sitting in a DirectX namespace, because this is like functions for loading a DDS texture, creating a Direct3D element runtime resource for it. So it's like Microsoft code that I've just completely gutted and created all these kinds of, like, there's a D3D12 loader here, there's a metal loader, there's a Vulkan VEZ loader. Here's the Vulkan loader that I used for my previous Vulkan backend, which didn't use VEZ, so there's one for those as well. The VEZ one is significantly easier, so this is not super excited. Like all of this code is just like exactly copy pasted from the DirectX version. The only slightly more interesting part is here in create Vulkan VEZ resources, where we quite simply go through. We create the images with the correct MIP counts and array sizes and everything, and then we go through all the slices, all the MIP levels, and we fill it with data. So essentially, when we reach this part, all of the DDS crap has been sort of peeled off, and we are left with the raw image data, and we can actually you can actually load it. So that's pretty nice. But yes, when we go back to our texture, we can see that we create 2D is the method that actually creates the 2D texture, and we can either have a DDS buffer, in which case we just feed it to that, and this is it. This is like all we need to do. Hopefully, but it did seem to work quite nicely with the VEC samples. If we don't have that, then we will want to actually create it by hand. And I was thinking we could maybe just copy paste that code from where we were. So let's take this guy, put it here and put it there. Right, so what do we have? VK format, get the Vulkan format. That's not really how we want to. Let's just do get format m texture description format, right? Image type. That's a VK image type 2D. We don't really support any other type currently. Type 2D and type 2D array. That's fine. We can add support for more types later if we want to. Right, so we have format. We have width. That would be m texture description width. And this would be m texture description height. And I think that's just 1. For now at least. MIP count. Actually, these are uint32s already, so we can take those away. MIP count is just MIP level count, and array layers is array length, and then sample is, yeah, it's just that, yeah. And tiling optimal, this is, I got burnt by this a little bit with my previous Vulkan renderer, but it would seem like it's probably best to just keep this as optimal. That means that we're going to actually have to create these in GPU only memory, as far as I know. Maybe not, but if we want them in GPU only memory, we have to use tiling optimal. I think that's like the way it actually goes. And that means that when we write to and read from the texture, we have to do it through like staging textures, but that's probably what we want anyway. So let's leave it like that for now. Usage flags, what is this? Yeah, that's not gonna actually fly. We're gonna actually have to look at the texture description and come up with some usage flags for this. But that's fine. Let's do that in a second. Texture, well, this would be MVK image. So let's have a look through these. Make sure I haven't gotten anything wrong. It looks pretty good. Looks pretty good, except this one. So let's do like get usage and texture description, and we'll figure out some usage function. So it's supposed to return one of those. And put it here. This is how I typically do get usage. Was that what I call it? Yeah. And it will take one of these guys as the input. And so what is the usage then? It can be all kinds of things. This is again like, oh, there's so many things that can go wrong. But I think we'll want the sample bit always, right? So usage flags, we want that one, and if we want to write to it, so if we have pixels or desk usage, CPU access is what it's called, yeah. If it's write only or it's read write, right? Then that means that we'll want to actually write to it, and it will need to have what will it need to have? Some transfer something or other. Transfer attachment bit, no, transfer destination bit, yeah. We wanna put things, transfer things to it. And then kind of similarly, we don't need the pixels bit here, but if we want to read from it, so it's read only, which is very unlikely, or read write, then we want the transfer source bit, because then it's the source of whatever we want for it, right? Hope that makes sense. And then desk dot flags, we need to put the, like if this is a GFX API texture flags render target. I remember this because it's essentially the same as we do with the D3D one, at least. So this needs to be it needs to have this color attachment bit. Oh, we don't want to save any output. And it also needs to have the transfer dist bit. Why is it complaining? I don't know. And then if we are doing a depth stencil texture, so texture flags depth stencil, it should have the depth stencil attachment bit instead. Something like that. And I think that is pretty much what we want. Like this thing here might be problematic. Like it's something that if we combine that with something that we're not allowed to combine it with, then we're gonna burn ourselves. But let's see if the validation layers tell us something. That typically you'll want to have this here, because you're most likely going to sample it in some shader somewhere. So that looks pretty good. Let's read through this one more time. If we have desk pixels or CPU access is write only or is read write, then we do transfer destination bit. If we are read only or read write, then we do source, transfer source bit, texture flags render target, then we need color attachment and the destination bit. Depth stencil, we need the depth stencil attachment. Yeah, that looks fine. We can start with this at least, and then see what happens. I'm sure it will shout at us if we do something that we're not allowed to do. Okay, so the only thing that we need to do still at this point is I'm gonna kind of separate that out. If we have pixels here, like you can create a DDS buffer. You only get if you are loading a DDS file, unsurprisingly. But you can create a texture just at runtime and then fill it with some pixel values. And if that is the case, then you actually read the data from this pixels instead. This is just a raw binary array, like a string of bytes, essentially. And if we do that, then we fill it, and we fill it with this guy, so we can just copy that guy and put it there. But we need to make sure that we're actually doing the correct thing. So I think we'll use just... This doesn't support all the kind of fancy MIP levels and arrays and whatnot. It just supports essentially the first level. So that would be like extent width, to make sure it matches like what we created up here. And this would be height, and that's probably 1. Yeah. And then again we have the device over there. Oh, come on. And we have the image over there. And this is supposed to be mTexture description pixels. Yeah, that looks pretty good. So we're creating the texture, or image, and here we're uploading to the image, which is actually kind of tricky to do on Vulkan, but VEZ just makes it very, very easy. All right, so MIP level 0, base array level 0, layer count 1, offsets are 0, and extents are width, height, and 1. Yeah, that looks pretty good. Looks pretty good. All right. And that built at least. Let's see. Do we actually get in here if we run this? Yes, we do. And we're creating something. I don't know exactly what this is. Oh, it's our HDR buffer. Okay. That's fine. We don't have any pixels, and well, it seems to have succeeded. We didn't get an assert failure at least, and here we're succeeding again. So yeah, this looks good. It doesn't really tell us that much yet, but it looks pretty good. Right, so I think we're almost done with this class, but we still have these things to fill in. So let's just quickly do that, and I can actually look at some other versions that I have here to some other backends for inspiration. This is just height. And this would be MIP level height, right, and then we call down to another one of these guys with the data and MIP level and texture array element, 0 and 0 and width and height, right? So just writing to the whole thing, width and height is the full thing, and 0, 0, no offset. That's like the default one essentially. And the right data is essentially the same as we did here. So this is kind of nice because we can just take this guy, bk result, and now we need to not mess this up. So MIP level is MIP level, texture array is that thing. Layer count is 1. Yeah. Yep, we write one layer at a time, one MIP level at a time. Image offset is like int x. I think these are ints. Aren't they? Yeah, they're integers. They're signed integers because you can offset them into negative land if you want. I can't actually currently do that because those are uints, but whatever. So xy And then this would be, I guess, width, yeah, and height. And that's not that, but it's data. Is that it? Was it that simple? Let's have a look. MIP level, texture array element 1, x, y, 0, width height 1. Yeah, that looks pretty good, actually. That looks pretty good, actually. And then we have another. What's the difference between? We have a source row pitch. Does this guy have anything like that? Data row length. Yeah, that's probably it. Source row pitch, data row length. Yeah, that sounds about right. So let's put that there. Is there any other difference? I don't think so. Yeah, so that's probably it. And I think this actually is pretty much what we need for textures for now. So now we can create textures at runtime, or we can create them from DDS resources. We can set them as write only or read write, read only or read write. They can be render targets, they can be depth stencil targets. We can read data, but we can't read. We can write data, but we can't read data yet. That's something that Metal doesn't do it either currently. D3D11 does. It's only used by the tools. We can create the image views, and this should make it pretty simple, or at least relatively simple, to bind these guys to render targets. So that's nice. We destroy the texture properly, and there we have the creation of it. Yeah, this looks pretty good. And it builds. Okay, so high hopes. This was actually everything we needed for textures for now. Excellent. Okay, so I'm gonna end this here. Next time we will bind these guys to the render targets, and then we can probably start with the buffers finally. And when we do that, we can actually get further than, like, if we run this, we still probably just crash in that one place with the buffer is 0, right? Yes. That's good, because that also means that all the new code that we have written doesn't actually crash. Just all the stuff that it happens to run through, like loading textures, seems to work. So that's nice. Excellent. And when we have the buffers working, then we have essentially we have pipelines left, we have render context left, we have shaders left to do, but there's not like a huge amount of classes left to do. So when we get those done, then obviously the fun things start, when you can actually see the result on the screen. Anyway, thank you for following along, and remember to hit all the buttons and like all the things, and I'll see you in the next one. Bye.